Hi, good afternoon, everyone. So today's lesson is called Simplifying Radicals. This requires you to know your times tables pretty well, so make sure that you're equipped with that before we begin. All right, so we're going to begin with a warm-up. I'd like you to find the perfect squares of these four problems. So go ahead and pause the video and do that. All right, and when you do that, you should figure out that the square root of 64 is 8, 144 is 12, 225 is 15, and 36 is 6. Now remember, the square root means what number times itself will equal the number under the radical. That is different than dividing by 2. So an example of a common mistake is that someone would just take this divided by 2 and say that this equals 32. That is incorrect. Remember, you're trying to figure out what number times itself is the number under the radical. All right, so these are plain numbers. Let's try variables this time. Okay, so go ahead and pause the video and see if you could figure out what number times itself equals the number under the radical. All right, and when you do that, you should figure out that x to the fourth times x to the fourth equals x to the eighth. And that's because our variables rules, or our exponent rules that we learned in the beginning of the year, showed us that when we multiply, we add the exponents. So for x to the fourth times x to the fourth is x to the power of 4 plus 4. All right, same thing here. What number times itself equals x to the 16th? That's going to be x to the 8th times x to the 8th. So your answer here will just be x to the 8th. Your answer down here will be x to the 5th. And your answer down here will be x to the 6th. So essentially, it's like dividing it by 2 because we know that these numbers times themselves will give the numbers under the radicals. All right, so these are all perfect squares. That means that there's one clear answer. What about non-perfect squares? You can see here in our practice round that we did the square root of 64 equals 8. But what happens if it's the square root of 63? We obviously know there's not going to be one clear answer. So there's a strategy we can use to figure out how to simplify this. Let's start by figuring out what numbers go into 63. We want one of these to be a perfect square if possible. Okay? So, what numbers go into 63 with one of them being a perfect square? I know 9 times 7 is 63, and 9 is a perfect square because I can take the square root of it to get a whole number. So I'm going to rewrite this. The square root of 63 equals the square root of 9 times 7, because under the radical, they are equivalent. Right now, I can circle 9 because that is a perfect square. And I know that the perfect square, or the square root of 9, equals 3. What that means is because 3 is a whole number, it no longer needs to be under this radical. I can move it to the outside. What that looks like is I have 3 on the outside, and the only thing remaining under my radical is this 7 right here. So I keep it underneath the radical. My final answer is the square root of 63 equals 3 times the square root of 7. And I can double check that on my calculator by putting those two values in. Square root of 63 is 7.9, and then 3 times the square root of 7 is also the exact same thing. So I know that my answer is correct. All right, so let's try another example. Same thing that we did before. We're trying to figure out what numbers go into 150. So like I said, this isn't a perfect square. We know, for example, 144 equals 12. This 150 is a non-perfect square. So what numbers go into 150, and we're going to try, if we can, to make at least one of them a perfect square. And if you can't do that on the first try, that's fine. Well, I know 25 is a perfect square, and 25 times what is 150? 6. So I can rewrite this. Instead of the square root of 150, I can rewrite it as the square root of 25 times 6. I'm going to circle the square root of 25 because I know I can get a whole number from it. The square root of 25 equals 5. So that's what I'm going to pull out outside of this radical. It no longer needs to be under this thing anymore. I can pull it out with a 5 on the outside. And the only thing remaining, since these essentially cancel, is the 6 right here. I keep it under the radical, and my final answer is going to be the square root of 150 equals 5, the square root of 6. If I'm ever confused, because this is a new lesson, I can just double check on my calculator. So this equals 12.2, and 5 times the square root of 6 is the exact same thing. So I know that my answer is correct. Yep, and that's essentially what we are going to do today. Let's go ahead and actually give you an example. I think we're going to go over this mostly next week, but I'll give you a preview for now. This is also not a perfect square, and I know that because this exponent is odd. So let's say, for example, let's say it's the square root of 8. I know that x to the 4th times x to the 4th equals x to the 8th, a number times itself. So the square root of x to the 8th is just x to the 4th. I can't do that with this number because it is odd. So what I'm going to do is I'm going to figure out what numbers go inside x to the power of 7. So I know x to the 6th times x to the 1st is equivalent to x to the 7th. Now I can do the exact same thing, and I can circle my perfect square, which is the even number. The square root of x to the 6th is x to the 3rd, and that is the number that I can pull outside of the radical. X to the 3rd goes on the outside because it no longer needs to be under the radical, and the number remaining is this right here, x to the 1st. I don't need the exponent to the 1st, and that's what I can keep it as. So my final answer, which I will double check in 1 second, is the square root of x to the 7th equals x to the 3rd to the power, or square root x. All right, and there's no way actually to double check this on the calculator because I can't just put an x. But I can tell you right now that this is the correct answer. You might see a pattern here for our last example. This is odd, so I can't figure out what number easily goes into it by multiplying by itself. What I'm going to do is rewrite this with a perfect square. The number below it is x to the 10th, and I know that's a perfect square. And x to the 10th times x to the 1st is equivalent to x to the 11th. I'm going to circle this. It's my perfect square. And I know the square root of x to the 10th equals x to the 5th. That is the number I'm going to pull outside of my radical. And what is remaining under here is just x to the 1st, so x. My final answer is going to be x to the 11th equals x to the 5th times x. Again, no way to check this on the calculator because we're working with variables, but this is correct. Okay, so I want you guys to pause the video right now and let's transition over to Delta Math. All right, so let's begin with this first one. This first one is pretty great because it's guided. So it tells you all the answers step by step. So these numbers are slightly larger, and I'm going to let you guys use a calculator just to help you with the multiples. So I'm trying to figure out what numbers go into 216, and I want one of them, if possible, to be a perfect square. So let's see, maybe 16. Let's see if 16 goes into it. So 216 divided by 16. That does not go into it easily. So let's try a different number. Let's see if 4 goes into it. So let's see if one of these can be 4. Yes, and 216 divided by 4 is 54. So let's use that. All right, so over here I can do 4 times 54 equals 216. Yep, and since it lets me continue, I know that that's correct. One of these is a perfect square, 4, so I can take it and put it on the outside. Square root of 4 is 2, and I can keep the 54 under the radical. Yep, and since I can keep on going, I know this is correct. Now I want to figure out what numbers go into 54, and one of them I'm trying to make a perfect square, if possible. All right, well, I know 9 is a perfect square and it goes into 54, and 9 times 6 is 54. So I'm going to try that. 9 times 6. Yep, and that works. I can keep on going. The square root of 9 is a whole number, which is 3, which I can pull outside of the radical, and I keep the 6 as it is. All right, so I'm down to one of my final steps. I can simplify outside the radical 2 times 3. 2 times 3 is 6, and I keep the 6 as it is, and that is my final answer. So if you are confused, you can go through the explanations. They give a pretty good description of the process. You guys are going to have 5 of these types of problems. For this one right here, 288, another huge number. I know it's even, so I'm just going to divide it by 2. All right, so 144 and 2. So 288 is the same thing as 144 times 2. So those are the numbers I'm going to try to put in. It's actually not that bad once you work it out. I know that 144 is a perfect square. It's 12, so I can pull it outside of this radical. And this I can't simplify, I keep as 2. And look, that's it. I submit my answer, and that's how you do the first types of problems. The second one right here is the same thing, but it's not guided. So instead of having those steps that you walk through, you're kind of just given the question and you need to solve all the steps by yourself. 192, I know it's even, so I'm just going to go and divide it by 2. So I begin with the square root of 192, and I'm going to change this to 2 times something. 2 times what is 192? It's going to be 80. Let's just double check this. Okay, so 2 times 96. Okay, so let's keep on going from here. Right here, I do not have any perfect squares. So what I can do is I can keep on simplifying. So I have the square root of 2 times, and then what can I simplify this as? What two numbers go into 96? Let's try 4. Yep, and that's perfect. I have 4 times 24. So 96 becomes 4 times 24. I see a square root, a perfect square right here, 4. So I can take the square root of 4 and move it to the outside of the radical. Square root of 4 is 2, so that's what I'm going to do. Left over inside my radical is 2 times 24. Is there a square root that goes into any of these numbers? Well, I think 24 is the easy one. I know 4 times 6 is 24. So that's what I'm going to rewrite it as. I'm going to drop down everything else. I'm going to circle 4. because it has a perfect square, and I'm going to move that perfect square to the outside of the radical. The square root of 4 is 2, so I'm going to add another 2 to the outside of the radical. I drop down everything else. I have 2 times 6 left over here, and I can simplify this. 2 times 6 is 12. So under my radical, I have 12. And I can simplify this right here too. 4 times 4 is, or 2 times 2 is 4. Final steps, what goes into 12? I know this can be rewritten as the square root of 4 times 3. And I keep my 4 on the outside here. This can be moved to the outside. The square root of 4 is 2. So I move 2 to the outside times 4. And then what's left over in my radical is just that 3. To simplify this, my final step, 2 times 4 is 8. And in my square root, I have 3 left over. So let's see if this works. Yes, and it does. So that's what these problems are going to look like. Let's try one more. The 72 is going to be much easier. So what numbers go into the square root of 72? 9 is a perfect square, and I know 9 goes into 72, so I can do 9 times 8. Since 9 is the perfect square, I can take the square root of 9 and move it to the outside of the radical. That's going to be 3. And what's remaining inside the radical is 8. I know that the square root of 8 is equivalent to the square root of 4 times 2. And don't forget the 3 on the outside. This is a perfect square, and it equals 2. So the 2 can be moved to the outside. I rewrite everything else. The 2 remaining in here can't be reduced anymore, so this is my final answer after I simplify it. 2 times 3 is 6, and I keep the radical with a 2 underneath it. And that's how you do the second one. If you guys have any questions or if you guys need additional support, I'm going to link this Khan Academy on your Canvas. So if you guys need extra help after your Delta Math, we're actually going to scratch this one, so you won't need to do the third one, just 2 tasks for you guys. If you guys need extra help, I'll link this Khan Academy and you can review this to see, to have some extra support if you need.